afternoon all. Welcome to the Post-Conclave event. So today we have our project manager of KISM. So he will introduce about the project and then we proceed. So Mr. Deepan Kumar.
So good afternoon to one and all present here. Thank you Priyanka and the entire KISM team at IIT Gandhinagar for this opportunity. So I'm Deepan Kumar from IIT Madras. So I'm the senior manager for this industrial energy assessment cell and this KISM project. So to brief on this IEAC, this industrial energy assessment cell. So actually we have established this IEAC at IIT Madras in the year 2018. So the primary objective of IEAC is to support the industries to save their energy. So by means of conducting various kinds of energy assessment studies from our campus side. So on this IEAC, so actually this IEAC was established or founded by 7 professors from IIT Madras from various departments. So we have started our activity in early 2019 to do energy audits for the industries, and our first client was Britannia at Chennai. So we started with the journey from Britannia, and so till 2020, early 2022, we have completed almost 14 to 15 detailed energy assessments and more than 50 walkthrough energy audits under this IEAC. Then actually we got the CSR support from Kotak Mahindra Bank in March 2022, where we have established this project called Kotak IIT Madras Save Energy Mission, this KISM project. So this KISM project has been established at 6 other IITs apart from IIT Madras. IIT Gandhinagar, IIT Ropar, IIT Indore, IIT Bombay, IIT Hyderabad and IIT Guwahati. So we are operating this in 7 IITs. Here under this initiative or this KISM project, we do energy audits at free of cost for MSMEs. Actually, we don't charge anything for this, the audit service we provide for the industries. The only thing the industry has to take care is our travel and the accommodation for the energy assessment team from the respective IITs. So far we have done about 125 energy assessments under this KISM, under 16 different sectors across India. So the fortunate thing is IIT Gandhinagar have covered more than 9 sectors among these 16 sectors in this entire KISM project, and the entire zone, I mean in actually Gujarat we have a lot of potential for I mean like there are a lot of energy, I mean industries, process industries in and around this belt. So we have a lot of potential for energy audits and to save energy. So the primary objective is to conduct a detailed energy assessment. Then after the energy assessment, we will submit a detailed energy audit report for all the industry people, where we will just identify the potential energy conservation measures along with the investment cost, the ROI and everything, so that once after having the report, the industry people can have a complete idea of where they are lagging in terms of energy usage, and like by means of what are all the measures they can save energy. And also we provide after the audit post-assessment support for the industries by identifying vendors for implementation of this ECMs. So this is a brief, a very overarching brief about this IEAC at IIT Madras and about this KISM project. So now I just request the team at IIT Gandhinagar to go ahead with the presentation. Thank you.
Thank you, Deepan sir. So we are focusing on the what challenger we are facing for the energy audit in MSME industries. So first problem is that they have the financial barrier, as the industry is small, so they don't have the sufficient amount to spend on their technology or on machinery to get like better machinery. They don't have awareness that there is lot of government scheme which provides them the money for their technology innovation or any upgradation. Second thing is like the limitation of technology upgradation means they do not aware of their new technologies available in the market which reduce their energy conservation as well as improve their energy efficiency. Next thing is like resource limitation. Like they have very minimum resources. Like in industry, if we talking about the manpower, skilled manpower, so they don't have that much of skilled manpower. So that they are just like limiting about how to do something, like how to do the measurement, how to check the machine is performing efficiently or not. Second thing is negligence toward energy conservation. So they only know how to like do the production, but they don't take concern to check their energy. Like why for the same production like this month EV bill goes high, and for same production why next month that bills goes down. Next is like same that I had mentioned, that technical skill and availability of manpower is very limited in the MSME sectors. Another thing is just like if we talking about the energy efficiency and conservation, so basically the people are very like it's very difficult to understand like what is efficiency and what is conservation concept. So basically, if we are taking examples and just discussing about what is efficiency and conservation, so if example in energy conservation, what we are doing, like example, if we are sitting in the room and we switch off the lights for example 2 hours, but this is the conservation. But if we're talking about the efficiency, but then we will talk about how efficient the lighting is. Example, like we are using normal filament bulb and we switch off it for 2 hours. That is a conservation. But if we replace that filament bulb with LED, then it will be the energy efficiency. So this is the basic difference between energy efficiency and energy conservation. So next thing, as Deepan sir told you, like how this Kisam is started and how we are covering the sector. So basically, the Kotak Bank coming forward for CSR project to the IIT Madras by seeing their previous work in energy audit, and they are generally focusing on the MSME sector, micro, small, and medium sector, and try to enhance their overall energy consumption. Next thing is just like they have the lack of technical skill manpower, and they are negligence toward energy efficiency. So that Kotak wants that someone who will do energy audit for free for them, so that their waste, their electricity bill, cost of operation, everything should minimized or optimized. Next, the recommendation we are giving in our report is not only on the report, like it will be implementable. It is just not for mentioning that we are going to give the 20 ECM, and this 20 ECM they find difficult to implement. So we are suggesting that implementation, that recommendation which are highly implementable. Next, what is the key benefit to industries? Because at last, if the industry will benefit, then our goal will achieved. So for that, if we are as a IIT Gandhinagar platform, if we going for audit for any industry, so first thing is like their financial barrier, which is like if they want to do energy audit from outside the firm, they have to pay some money for doing the energy audit. So their one financial barrier would optimize. Second thing, as a research institute, if we are going to any industry, we find different problem which reduce their production, and maybe that specific power consumption will increase. Means producing same product with consumer electricity will be more. So for that, if we are just preparing the problem statement for that, and that we study under the professors, so that we will find any result, and that will implement in the industries. Next thing is sometimes energy auditor give the suggestion, but industry find it difficult to how to implement and how to proceed further. So we are also providing like post implementation help. So, like example, like if we suggest any technology, and sometimes the different vendors give different quotation, and they find like difficult how to choose or how to select anyone. So on that platform, we are also helping them, like which technology you will choose, so to make your system highly efficient. Next is what scope we are covering in our energy assessment. So starting from electricity bill, so we what our plan, like first we take the electricity bill, that is 12 month, like we study the annual electricity bill, like how what is the electricity consumption pattern. If it is like process industry, it will continuous, or it is like seasonal load. So on this bill analysis, we are doing everything. Like we are checking what is the night tariff. Are the industry are taking the benefit of night tariff, or like example, like major time they are their production is running on time of usage. So that time they are penalized for using electricity. And also we are also checking what's the power factor they are maintaining. If the power factor is less than 0.9, so they are penalized by the transmission company. Next is the harmonics monitoring. In our study, we are also used to monitor what is the harmonics level in the system, so that if like example, any like failure in the instrument will take place, so we can know why what is the reason for the failure of the system. Next, like sometime we find like in electrical panel there is some heating issue. Because of that, sometime that cable burn out. So for that we are doing that electrical thermography of the panels to examine in which lux or in which cable is overheating. Then coming toward the utility performance, so we are covering all utilities, including electrical as well as thermal utilities. For that, like compressed air system, we will monitor compressed air system in transmission as well as generation side. So like what is the compressor is generating by taking a specific power consumption, and how the distribution system is. So we will also check that inside the plant if there is any leakage in the system. So we will point out and suggest them, if you if you attend that leakage, you got the savings. Next thing is that boilers and cooling towers. So in boiler also, that sometime if we talking about small thing, the insulation is damaged. So if we remove the insulation, or do proper insulation, so that this should be minimized. We also study about the steam consumption and all. And apart from that, we are also monitoring the flue gas parameters. Like in flue gas parameter, if the excess air is more, so how to control it so that our fuel consumption will reduce. Next thing is like cooling tower and chilled water system. So in chiller we examine like what is the flow in the evaporator, or what is the actual TR generation with respect to the rating TR, and for generating that actual TR, how much power the compressor is consuming. So for that, and also we examine what is the condenser health as well as evaporator health, so that we can understand what is the complete profile in the chiller system, why this power consumption are increasing. So by doing these things, we are able to understand why the chiller performance is not good. Similarly, for cooling tower, we are also examine every what is the cooling tower performance and all these things. Next, for thermic fluid system, that industries are also having the thermic fluid heaters. In that heaters also same that we examine the flue gas analysis. In the flue gas analysis, we examine what is the O2 percentage in that, what is the combustion efficiency, taking direct and indirect as well. Next is motor load measurement. We are doing also the motor load efficiency testing, and also what is the current the motor load is. Example, if any motor is running less than on 30% of load, so we will recommend how to improve your efficiency without affecting your process. Next, pumping efficiency. We often observe in the industries, like if they design the last pump, so they throttle the wall and doing their works. So if we throttle the wall, the pump characteristic is just like pump. When we throttle the wall, the pump head will increase and flow will reduce. So ultimately the power consumption will remain same. So for that we can use VFD or whatever the good practice will be, we would recommend. Next is sometimes the industries had a problem in demand pattern. So example when during the starting time or something, like when we start all the load at a time, so that time the our demand pattern will increase. So for that we suggest them how you would optimize your load so the demand penalty will reduce. Next, the blower vacuum assessment. So what is the blower vacuum is maintained in the system or not, and how much blower of fan efficiency would be. Apart from that, we are also start working on water conservation and water saving. So what we do is rainwater harvesting is possible in the system, or recharge board is possible in system. So we give that their feasibility study also. And in this, whatever the instruments we are using, we are going to demonstrate here. So after the end of session, if anyone interested, they can see this. Next, how we are different from conventional energy audit. So basically, our focus is on implementation. Like we are majorly suggesting only that recommendation which are implementable. Even we are thinking every aspect of the MSME, like if there is financial, where how they will implement. So we are suggesting only that, or how to retrofit the system. We are suggesting that audit report which are only focusing on the implementation strategy. Next is our report is just like that, focused on what is the innovative solution any industry should adopt to improve their efficiency or efficiency. Next, we have special equipment for adjustment which cost around 35 lakhs, and it is just we can use that instrument, and this is like a very good instrument, and we can able to generate the report from that also. Next is just we had the organized structure of audit. Like first, what we do, like when we visit the plant, we just do the walkthrough audit and take their electricity bill, so that we can find where the major saving scope for the industries, and then we do the detail audit. After detail audit, like we do a thorough study of the plant, and then after after that detailed audit report submit, we went to that industry, and then we just demonstrate about that what is the report tells about how you going to implement these things. And after 3 or 6 months, we went for the post assessment. Like if after installation of any system in for energy savings, how much saving have you achieved or not. Next, if any industries find difficulties in implementation, so we also help them to how to implement, or if they want any technical supports from us. Basically, and this is as a CSR fund, so that is no cost to energy assessment for MSME. Apart from this, we are also doing the how much emission will be reduced when you are saving X amount of energy. So these things we are covering in our report. So this is a faculty expert in from IIT Gandhinagar team. So Professor Naran Pindoriya, he is from electrical department. Dr. Chinmay Gorei, he is from chemical department. Dr. Atul Bhago, he is from mechanical engineering, and Mr. Rajendran, he is from electrical engineering. So basically, our team is like a multidisciplinary, and we have take the input from electrical, chemical, thermal as well, so we can monitor the all aspect of any industries. And this is our energy assessment team, whom I, Priyanka Shrivastava, Rahul Patel, Selva Ganesh, Sagar, Faizan, and Abhay. So these are the some electrical and mechanical combinations, so that we perform a good study in this in the industries. So these area we had covered in IIT Gandhinagar as a cluster base. So we had already covered that cold storage in Himmatnagar area, chemical cluster in Ahmedabad as well as Ankleshwar unit, pharma in Ahmedabad, and paper pulp industries in Vapi, textile cluster in Surat, diamond and jewelry in Surat. We are also targeting the fishery sector, which are is Porbandar and Somnath. Chalk duster is a unique cluster in India. It is only in Junagadh, so we are also targeting that. Then ceramic cluster, which is a highly intensive and highly energy intensive industries. We are also do the audit at Morbi, and then the laminates and timber industries in Kutch. So as of now, we had covered 23 clusters, out of which we are doing 46 walkthrough audit. And in this 46 walkthrough audit, we converted this 21 detailed energy audit, and remaining we are sending the walkthrough audit reports. After conducting this 21 energy audit, the CO2 emission proposed reduced is 20,000 metric ton, and this last year we had done the audit, so some of the industries had already implemented all the energy conservation measures. So from that energy conservation measure, we had reduced 3610 ton of CO2 emissions. So this is generally a graph which are showing how many industries we had walked through and how many industry we had finished. So for CTP plant, we had done CTP industry, 2 in Ahmedabad, and one in Ankleshwar, and one also in that Vapi region. Next is cold storage. We had done cold storage in different area, Himmatnagar, Modasa, and Dehgaon area. Similarly, for steel industry, we had do the walkthrough into industry, but out of which we converted 2 in detailed energy audit, which are from Ahmedabad itself. Next, these chemical industries, we are covering chemical industries from Ankleshwar as well as Ahmedabad. Textile is also from Ahmedabad as well as Surat. Diamond industries are completely from Surat. We had done the walkthrough in 7 industries, and out of which 2 industries we are going for detailed energy audit. Next, ceramic industry, we had done 1 ceramic industries audit, and 3 walkthrough completed, 2 are in line. We are going to complete this audit in December month. Next is paper pulp industries. In this, we had done 1 detailed energy assessment. Seafood, we are going to do the energy assessment in in November month. Timber and laminates, we recently completed 1 timber laminate industries, and 1 we are going to finish in November month. Building, we had done 1 energy assessment of building, and similarly for rubber plastic, we had done walkthrough audits. For pharma sector, we had done walkthrough of 3 industries, and detailed energy assessment is 2 industry we had completed. So this is the cluster-wise saving, like the industry which had already implemented our energy conservation measures. So in this CTP plant is the first plant we had done the energy audit. So in that plant, if we are assuming the total we had in our energy savings measure, they have implemented 12.5 like 13% of our conservation, and their energy saving in the term of their electricity bill is 13%, and saving in the term of money is 650 lakhs. Similarly, for cold storage, the number of units we covered is 5 units. Saving we identified is 55%. Out of 55%, 30% our savings they achieved. Similarly, for steel industries, we had covered 2 industries, and we recommend the saving of 90 lakhs, out of which 10% of saving they already achieved. Similarly, for chemical industries, 3 units we covered, and 201 lakhs saving we identified, and in which 5% of saving are actually achieved, because the remaining are still for installation or pending. In textile industries also, they we recommend 46 lakhs, and in which 5% is now they had implemented and achieved the savings. And diamond and jewelry also, that it is 7.2 lakhs, and the saving they achieve is 14% of the recommended savings. Ceramic industries, we recommend a saving of 197 lakhs, and they implement one or two measures and achieve 8% of savings. So we also, apart from this, we also doing the awareness session at different area in Ahmedabad. That is, we are also doing awareness session is Junagadh, Ahmedabad, SGCI, Surat, MSME office Gandhinagar, Vatwa GIDC as well, and Porbandar. So this is our team with MSME industries, and these industries are participated in our energy assessment event. So basically, if this is the procedure to participate in our energy assessment. So for this, if anyone, student or industry member would like to join us, so they will scan this QR code, and in this QR code, after filling their basic data, we will get the details, and if he is interested in audit, we will approach them about if they want energy audit to be done. So our procedure is like these things should be done, like we sign non-disclosure agreement. In this for doing this energy assessment or participate in this energy assessment, the registration number is required if they have. Then we also provide one assessment sheet in which the industry would provide all the detail regarding their industries or utilities, so that we can able to understand what are the utility equipments they have, and we will plan accordingly. Okay. Next, we will do walkthrough audit after receiving that assessment sheet. If any missing like any filling are missing, so we can go for walkthrough audit in industries and check about if anything is pending or any more data we want. So we collect all that data during walkthrough audit. Then after, we will plan for detailed energy audit. For detailed energy audit, it will take 2 to 3 days or more than 3 days. It all depends on the size of industry or the number of equipments they have. After completing the energy audit, we are doing one closing meeting in which we are highlighting what are the major observation or what would the action plan for implementation. Next is post-assessment, like after completion of 60-70% of implementation that we had recommend, we again conduct a post-audit for checking like how much actual saving they achieved. For presenting case study, I will invite Mr. Rahul to come here and present.
Good afternoon, everyone. Myself, Rahul Patel. I am certified energy auditor, and I am an energy assessor in this KSM team. So I will represent the case studies which we have faced in implementation of the energy conservation measures, as well as the case studies which industry faced during the implementation of the savings. This is first case study. We have 4 audits in CETP plants. So this is the case study of one of the CETP plant. There is a majorly in aeration section. In aeration area, CETP plant are having the aeration blowers, the surface aeration blowers that is supplied for aeration activity in the effluent. They need to maintain some effluent parameters to have a biological action in the to achieve a proper effluent treatment in the system. So in this plant, we observed something like the dissolved oxygen level. We observed they have a single stationary dissolved oxygen sensor on the outlet of the effluent stream, and the dissolved oxygen level is around 4, and it is varying throughout the day, as well as the dissolved oxygen level is depending upon temperature also. So during daytime and night time, both time the dissolved oxygen is varying. So we have suggested industry to have a portable DO sensor and to monitor DO sensor throughout the level, throughout the tank, because the tank diameter is having 70 meters. So this 70-meter tank diameter, the all stationary areas having different dissolved oxygen level. As well as for implementation of this ECM, we recommend these industries to have a active DO based monitoring system that can give a real-time reading of different areas. So industry implement like that way if they are having the system to measure the DO oxygen level in every shift. So depending upon the DO level, they can switch off or switch on the aeration blowers as per need. And with implementation of this ECM, the earlier power consumption for this aeration activity is 852 kilowatt at the instant, means it's a kilowatt power. At the time the all aeration blowers are consuming, there are 23 blowers in the system. And after the implementation of this ECM, there is opportunity to switch off four agitators or the aeration blowers at night time and 3 agitators at daytime. So implementing this best practice, the industry able to achieve the power consumption of 752 kilowatt. It is equivalent to 2400 units savings per day. So it is a significant energy savings achieved by the industries to have using this energy assessment. They introduce these savings throughout the year, and they are having good energy bill reduction as we can see in the graph. Next case study is the textile and chemical case studies. This is for the thermic fluid heater system. Thermic fluid heater system is the system, they are like the boilers. Boiler, they are using water to convert boiler to convert water into steam. In thermic fluid system, there is a thermic coil at the temperature of 250 degree. They are heating the thermic coil and circulate the thermic coil in closed system. So it is a small scale industry as we are doing the audits for the MSME. So this thermic fluid system is the major energy consumption in that textile industry. So this textile industry is having a demand of 285 kilo kVA, and among the 285 kVA, almost the 20% load is in only this system. And we observe that because this is thermic fluid system is recently introduced in the industry, we observe that the thermic fluid pump is a totally oversized pump. We measured the power consumption, we measured all the things, and we observed the thing like there are frequent loading unloading in thermic fluid pumps. The loading unloading reason is that if you can see the capacity of the thermic fluid heater system. There is a 45 lakhs kilocalorie thermic fluid heater system which is running on only 9 lakh kilocalorie load. So which is almost 20% loading it is running. So whenever the thermic fluid system achieve the temperature, it will cut off the bed, and after that it will again start after reducing the temperature. So in this pattern, they are having frequent start-stop cycles. We observed that thing. So we observed that the thermic fluid system that OEM suggested the industry, that is very oversized. Now they have purchased all the system, they have installed all the instrumentation and the necessary pumping system for the thermic fluid. Now we help, they cannot change the entire system. We help the industry like that, how they can retrofit in the existing system to achieve optimum power consumption. So first we do the impeller trimming of that pump, because that pump energy rated power is 37 kilowatt and consuming 50 kilowatt power. The totally oversized pump, and the OEM supplied some wrong size of impeller in that pump. So we identify that opportunity and trim the pump. So now the pump is having 37 kilowatt as per the motor specification and the pump, and we recommend to more reduce that pump with 30 kilowatt motor, so that they can achieve almost 20 kilowatt savings, which is equivalent to 7% of the total plant load. And that is significant saving they have achieved in this pump, because this system is having introduced in just 2 months back. So the OEM itself trimmed the impeller and supplied the trimmed impeller into the industry, and the industry having the savings with this implementation. After that, we recommend industry to have a reduction in that number of nozzles. Means they blind some nozzle, reduce their firing bed, so that thermic fluid output is 45 lakh kilocalories, reduce about 30 lakh kilocalorie. Because industry is having expansion in the future, so we are having keeping that mind. We suggested to cut the bed according to the requirement, and we resize the bed and redesign that bed. So significant fuel reduction, also almost 20% fuel reduction they are achieved with this implementation. 9.5 lakhs unit savings with the implementation of the pumps, and more 16 lakhs rupees saving they are achieved with the optimum pump and this bed recovery system. Then this is the case study for the spray dryer system. Spray dryer system having major application in CTP plants also, where we are having the spray drying system, as well as chemical and the ceramic sector also. all sector the spray dryer design and using are same, just the size is different. All spray dryer are used to vaporize the slurry and convert the slurry from liquid state to powder state. So hot air is used, which is generated in a hot air generator, and then the hot air is generated, that is around 550 to 600 temperature, whatever the requirement, and it is supplied to the vessel that called a spray dryer. And the spray dryer vessel, the heat transfer action between this hot air and the liquid slurry, the water evaporated from the slurry, and we are getting the powder of the our product, which is in effluent treatment plant. It is a solid waste or the sludge they called, and in the ceramic plant that is the product for that. So we have analyzed this system because this system is having too much large number of utilities attached with this, like a hot air generation system, the feed water pump, atomizer, as well as following the main vessel, they are having one cyclone system also to recover the additional powder or additional material. After that, there is a water scrubbing system, and at the final stage, they are having ID fan. ID fan is used to maintain a vacuum in throughout the system, because we need to have some vacuum to maintain the airflow, to maintain the ventilation in the system. On always the spray dryer system, they need to maintain this ventilation for optimum drying also. So there are some specifications that ID fan are designed. So here we found the ID fan is vacuum is we have vacuum study all over the spray dryer, and we found where is the loophole, means where are your vacuum is losing, because for generation of 50 mmWC vacuum in this system, ID fan need to generate 450 mmWC vacuum at ID fan suction. So at the suction, almost the additional 400 mmWC vacuum that is lost throughout the path. We are having a 3-4 system in the path, so vacuum can be reduced, but optimum vacuum that can be reduced is up to 150 mmWC. Here the main major vacuum loss is there, fresh air intake, where the product out is there. The industry don't having any flap valves or any closing. So the vacuum maintained in the cyclone or the main vessel, it is lost in from this system. So these are the images. These are the very critical case for the CTP plants as well as the ceramic and chemical plants also, because not maintaining the vacuum in the spray dryer also affect on the HAG system, which is same like a boiler. If we are not maintaining the boiler draft or negative, we need to maintain some negative draft in boiler. If we are not maintaining, it will pressurize our boiler walls, and as well as it can damage our boiler walls, as well as it can damage our hot air ducting also. So that is a very crucial thing to manage the vacuum, because this normal plastic bag cannot manage the vacuum. We need some low cost implementation, as we can see in the right side of the photo. We can see that the normal implementation like a flap valve we can introduce in the system that can maintain the vacuum in the system. When the solid material is near the flat valve opens, and other time the flat valve remain closed. So it will be a barrier between the atmospheric and the vacuum. So in the whole over the system, the vacuum is maintained. So this ID fan is having 24-hour running utility in the spray dryer unit, and it is having the major power consumption, almost 40% power consumption going into this ID fan only. So we can have significant savings through implementation of VFD in this system. Almost 40% energy savings. We demonstrated this vacuum-based system with VFD, and we can achieve up to 40% energy reduction in the spray dryer system. Next, there is some insulation losses. We are because the normal insulation that conventionally using and in normal practice, that is a glass wool insulation. Glass wool insulation is now having a outdated technology. Glass wool insulation having the thermal heat conductivity of 0.037 watt per meter degree Celsius. And after the year of the application, it will absorb some moisture from the atmosphere. It will absorb some dust from atmosphere. If the binder are evaporated, once the binder are evaporated from the insulation, this insulation become like a insulation property are lost. In the some old insulation, we can feel like the insulation is having too much heat conductivity as well. So we analyze this insulation in every thermal industries, and we can see the thermal image. These are the thermal images of thermic fluid heater. Thermic fluid heater system surface temperature gone up to 80-85 degree. So this is a direct heat loss, and accumulating all heat loss from the thermic fluid system, we can find that there is almost 10% heat loss, that we are giving 100% fuel, and 10% fuel is our lost in this, only in this insulation from the generation side itself. So we explain the industry to replace this insulation. Now industry having more, we suggested some sustainable product, because the glasswool insulation having the hazardous disposal also in the, we cannot dispose it like a normal waste. It is a hazardous disposal, and we need to give it to the proper disposal manner. So we recommend industry to have a modern insulation, that is a perlite insulation. Perlite is a material that is expanded from the volcanic ash. It is majorly the insulation is available. The raw material is available in Turkey and east region. So this is widely available and widely used in our building industries. So this can be used in the normal thermal insulation also, and these insulation are having almost 30% reduction in a good insulation property than the normal conventional the insulation. This insulation also having more than 50 years of life, as well as it is come with a solid section manner. So we can have the insulation that can be damages only if the mechanical damage is there. So this is a good insulation replacement done by the industries, and they have almost 36% reduction in the surface heat loss, which accumulate the 7% reduction in the fuel consumption. So the below image is that thermal insulation image, that is having the pipe section as well as square section also, and this thermal image is having after 7 years. We have seen some old application of that insulation also. We have analyzed that insulation that is having after 7 years, that is having 40 degree surface temperature. So it is having maintaining the good insulation property after the 7 years of life also. Then this is a specific case study of ceramic industries. Ceramic industries are using these ball mills. These ball mills are using for the preparation of the slip. Our tiles are manufactured from the clay, and clay need to be mixed with some binders, and this binder need to be in a liquid form to have a complete mixture, uniform mixture. So ceramic industries use this ball mill. In this ball mill, the image shown, the silica balls, aluminum balls are there. So that is used to grind this powder and liquid mixture, and maintain the uniform mixture in the for the process. For this, these ball mills are used, and it is having a significant energy consumption in the ceramic process also. So ball mills are having 180 kilowatt motor consumption, and the total cycle ball mills with the material and the liquids binder, they are rotating at some RPM at 7 hours to have achieve the proper mixture. So we identified that the industry has already implemented the VFD in the system, but they are using on a same frequency. We have monitored throughout the cycle, throughout the 7-hour cycle we monitored, and we observed that after initial 120, 110 minutes, the significant energy consumption reduction achieved in this ball mill pattern. So we have taken a trial to reduce the frequency, because motor is having 1400 frequency. So we reduce the frequency up to 45 and 40 hertz. We have taken the trial and see the difference in the ball mill rotation. We don't have any significant reduction in the ball mill rotation speed, and that industry doesn't require the torque that is initially required for the grinding auction. So after that, the slurry is prepared in a liquid form, so industry don't require that much torque. So after reduction in the frequency throughout the cycle, this is the curve plotted, and the curve suggests that with reduction in the frequency, we are getting some good energy savings. About 5% energy savings directly achieved during the audit. We have taken this trial during our assessment also, and industries are having 1.81 lakhs unit annual saving. That is a significant energy reduction in this ball mill, and they are have the 5 ball mills in the system. So they are getting a huge reduction in the ball mill system. Then there is another application that is a polishing process called polishing. The upper layer of our tiles, our wall tiles, bathroom ware tiles, that upper layer need to be polished to have that glossy finish. For that glossy finish, this type of machines are used, and this machine they are having a grinding wheel. The grinding wheel having pressurized by compressed air, and the compressed air pressurized grinding wheel rotating with 350 rpm over the tiles surface, and it will polish the tiles. So in this system, there is a challenges faced by the industries, like frequent failure in the these grinding wheel motors. They cannot achieve the constant speed. Some heat action is there, and some they cannot maintain the proper pressure of the compressed air system. So we thoroughly analyze the system. Leakage is arresting the leakage at every head. Every head is pressurized by the compressed air. So we analyze the leakage analysis, as well as we have taken the sleep analysis, sleep measurements, as well as the RPM measurement through the stroboscope. So we now identified some application of this motor protection device. Motor protection device is there. We can set the ampere, and after the significant achieving that ampere, motor can trip. So we identified that ECM because the failure is due to the operation. So operation error due to the unskilled employees are also there, because the local employees they are using for the operation. So due to their operation error, they are having excess pressure on the cylinders. When we are having excess pressure on the cylinders, it will convert it into excess load in our motor. So at that time, motor is not stopping. So we, after the introduction of this instrument, the motor is stopped whenever there is excess pressure on the system. So the motor failure rate is eliminated now, and our motor is saved, as well as when we rewind the motor, our 6.6% efficiency is lost. So every motor in the head, they are having 14 heads in row. So every motor having one or two times rewinding. So we recommend the industries to have a government energy efficient motor replacement policy. They are to adopt these ECMs. They have process some ECM, replace the motor, and have this energy motor protection device, and they get the savings now. So both problem solved. Means the motor failure rate is also eliminated, and the energy savings is also there. Next application is the for the cold storage. Cold storage application is like there. They are having like a three-story building. Three-story building are completely need to maintain the -1 degree temperature to have to maintain the freshness of our vegetables. So these potato cold storage system, they are using a refrigerant system. Refrigerant system is running through the refrigerant compressor. There are 4 or 5 compressors in the system. Initially, the industry is using the all compressor for all the times depending upon the temperature. But we recommend the industry to have a compressor with VFD and retrofitting. But the industry is having too much old motor, having 20-25 years old motors, and this compressor system are also old. And only the one compressor they can implement that is compatible with VFD. So they implement the VFD on that compressor. So whenever there is a charging or discharging material, whenever our heat loss is more, so at that time they run the non-VFD compressors also. At the other time, they can only achieve they have to only use that VFD compressor, and the VFD compressor, once the temperature achieved in the system, our cold storage are heavily insulated from all over the area. So with the VFD application, they can maintain the lesser refrigerant requirement also. So the industries before the year 2022 and after year 2023, they are getting around 25,000 unit savings per month for the implementation of this VFD. And this VFD cost they covered almost in 3 to 4 months. So that is a significant energy reduction, and the cold storage also. We are now approaching the fisheries which are having this is -1 degree application for maintaining the in cold storage. But in fishery, the cold storage they are maintaining -30 degree. So we are looking forward to again this application, and some retrofitting application in that fishery industries also. Now moving forward from the pharma industries. We have just recently completed 2 pharma detail audits also. The pharma industries are using the AHUs. AHUs are used for the maintaining the air quality, because pharma is the application like that. They need to maintain some higher standard in the fresh air quality. Means we are sitting in the room. These ACs are running. Same as the in a pharma unit, they are using AHUs. So the AHU are just a difference between a normal AC and AHU is the AHU are having higher flow. So higher flow, they need to maintain some ACPH. ACPH is called air change per hour. Means they need to maintain some standard to achieve the air quality. Means they need to have some filtration in the air throughout the system to maintain the ACPH and maintain the pharma standards requirement. So we also measured that thing also. Depending upon the area and the blower specification they are installed, we can measure the ACPH, actual ACPH what our blower is delivering. So we measured in the all over the industries, because all whole industries are having HVAC load. Main load is pharma is the HVAC load only. So we measured the ACPH in every area. So we got that some areas are having some highest ACPH than required. Means the blowers are always designed to achieve ACPH whenever it is worst condition in the filters also. Means once our air filters are choked, AHU is equipped with the multiple size of filters. So whenever our air filters are choked, it will giving the increase in our blower power. So to maintain that ACPH, and when ACPH blowers are designed to maintain ACPH at the fully choking of the filter also. So all blowers are always having the some higher design than it is required. So we observed that thing in these industries also, that is having 56 ACPH they are maintaining, where the requirement is only 20. Okay, so we recommend to do not change the blower, because whenever the filter choke, maybe the requirement is a higher capacity blower also. So we recommend to them to install a VFD on that blower and monitor the filter pressure drop. So this curve is plotted, this graph is plotted from the 15 days monitoring. If the filter cleaning rate is 15 days, so this is the energy performance throughout the 15 days, and with the application of VFD, the significant energy reduction can achieved in both days. So whenever we are having the normal ACPH, like industrial maintaining 39 ACPH, that can achieve 18% of energy saving, and the higher ACPH means 56 ACPH that can achieve the 28% energy reduction in the blower power also. As well as this is a specific case of pharma where the 3 rooms are connected. So the single AHU is used to supply the air of all 3 rooms. All 3 rooms need to be maintained with the same ACPH. Otherwise, one air will be if the DP level is different in between the room, and single AHU is supplying there, one room, small room may be feeling some starvation in the air supply, and another room having the excess air. So that is a critical case to maintain the ACPH in the pharma unit also. So we implement these savings, and suggested to have this normal monitoring system to monitor the choking level of the filters. So there are normal energy savings in utilities also. These are the specific cases for specific industries. Now the what are the normal practices we are following in the energy savings? Like in boiler, we can preheat our combustion air. Where this is normal practice now. Every boiler is supplied with APH. But if the boiler is not supplied with APH, every 22 degree reduction in the flue gas temperature can increase boiler efficiency by 1%. It is a direct relation. When we can supply the hot air in the boiler, we need to less fuel to heat that air up to the combustion temperature also. So that is one ECM we can implement. There is a major implementation of the excess air control. Our excess air is, if our excess air is higher, means carbon need to have some oxygen to for the proper combustion. That oxygen level we need to maintain in the boiler. If we are not maintaining that oxygen level, that is causing, if we are supplying low air than required, then it is generate of incombustible gases. It is generation of CO. And if we are supplying excess air, so some excess oxygen quantity will remain in the flue gas, that will increase the losses of the boiler. So we need to maintain some optimum oxygen level. We are checking this oxygen level in every boiler analysis, as well as the scale formation, sediments, some parameter that feed water quality we need to maintain in boiler. And there is a fly ash and soot formation also in the boiler coils. We need to check this condition, because the 3 mm thick soot can be increase our energy consumption by 2.5%. We during boiler analysis we will check all these things, so we can have the glimpse like what are the normal ECMs that industry can implement. Then there is significant energy reduction we found everywhere is the leakages of steam. Now steam, why the steam leakages are happen? Steam leakages whenever there are having the steam are having the wet condition, means we generating steam at a dry condition, means we are generating some specific saturation condition steam, but during the traveling during the insulation losses, our steam is converted into some moisture, and the dryness fraction then introduced. Whenever there is a joint, there is a gasket fitting in the system. Always there is a gasket fitting, because the streamline is totally a big distribution. So there is a weakest part, and whenever there is a excess moisture in the system, it will create the leakages in the system. So the leakages are not that much that we can neglect the thing, because a 3 mm diameter leakage at 7 kg pressure in the streamline can have 71 ton coal equivalent coal loss annually. So this is a very significant leakage that we cannot neglect. In some very industries we are seeing that they are having negligence about the leakages. So there are some serious cases that can be the reason for accidents also, and that can be the reason for efficiency loss also. As well as the steam system is need to provide some air-free steam distribution, because we need to vent some air that is introduced in the steam distribution system. The air venting is necessary, because it can have the expansion action, it can having the water hammering action also, and the 25 mm thick air can be it can be act as an insulator. So air is damaging, it causes a damaging action. As well as this compressed air system. The compressed air system is the costliest utility whichever we are using. It is costlier than steam system also, because the compressed air system, if we consider the cost is almost higher than all over the utilities, depending upon the requirement. So the compressed air leakage, because air is free but compressed air is not. So we need to monitor the leakages also. And the leakage monitoring, we have a dedicated instrument for arresting the leakage. That is the thermal acoustic imager it is called, and it is ultrasonic leakage detection, where the small air also can be detected, as well as the minimize the leakage access, the pressure drop also we can minimize in the system. So 1 mm air leakage can cost 42,000 annually. So every small air leakages also need to be addressed, and also the same like steam system, the compressed air are also having leakage due to the moisture in the system, because when there is a moisture, that is caused reason for the water accumulation and the weakest part of our distribution system, and that will cause the leakage. So we recommend we identify that leakage point, but we know that a leakage will always there. We need to remove the root cause of the leakage, why the leakage is happening. So the leakage we remove by the introducing our dryer in the compressed air system. So we optimize the compressed air with the dryer application also. Then this cooling tower system. Cooling tower is widely used in process industry as well as chemical industry. We need to maintain some loading, as well as there is a fields in the cooling tower. The field need to be maintained for the optimum level, for the optimum heat transfer. Cooling tower uses evaporative cooling technology, that is different than normal refrigeration. Means evaporative cooling, that are normal air cooler we are using in the home. We can easily get up to the wet bulb temperature, means up to 24-degree temperature we can easily get through that system. So if we need a temperature in a room that is around 25 degree, 26 degree application, At that, we can use that evaporative cooling system, same as the cooling tower. After that, if we want to more reduction in the temperature below 24 degree, then we need to use the refrigeration system, that normal compressor system. So the cooling tower system is having 0.06 kW per TR energy consumption, and the normal refrigeration that we are using at our home, that is causing 2 kilowatt per TR energy consumption. So that is a significant energy consumption compared to evaporative cooling and the refrigeration action. I would like to end this case study presentation. If any question from you, we can ask. You can ask. We will give the answer. And any students that want to participate in the energy assessment activity, then want to see the how this activity can complete, that can scan this QR, as well as this QR is available in our website also. So this is a QR they can scan and participate in the energy assessment. So any questions? Now moving forward, I would like to thank DISR CRTDH team for this conclave and all audience to be present here. After my presentation, I would like to call Abhay. We will demonstrate our energy audit tools and instruments that we are using for energy assessment in the industry. Abhay is giving brief introduction about what instruments we are using, and then we can have a live demonstration of our instruments, so that we can have a hand-on practice that how an instrument can operate it and what readings we are achieving. Okay, over to you, Abhay.
Everyone, this is Abhay. I am a project staff here. I am also a sorry. Sir, you can forward. Sir, you can continue. No problem.
The major instrument that we are using during the energy assessment activity are the normal instrument that we are using for power quality analysis is the thermal imager, as well as the flue gas analyzer, water flow meter, the thermal imager as well as power quality analyzer, stroboscope, the tachometer we are using, and for specific measurement of RH and the temperature, that are having a Bluetooth operated thermography, Bluetooth operated temperature hygrometer, anemometers also, and we are having some clip-on meters also for the energy measurements. These are the softwares what we are using during the because all meters are having data logging facilities. So to utilize the data logging facilities, as well as the analysis of the recorded data, we are using this software for power quality analysis. There are the data view software to measure the waveforms, as well as to analyze the recordings data, to monitor the deeps as well as the swells in the system. Then the temperature RH monitoring, we are using this instrument for continuous monitoring of the temperature RH, as well as we can record the data also. For the analysis of thermal image, that is a very critical instrument for the thermal system we can use. So we are using thermal imager and the dedicated software to analyze the thermal images. These thermal images can be explored more in the software to maintain measure the temperature where we are having not measurable through normal temperature meters. So that are our major equipments. We will display all the equipments after the session, and all equipments are available for the display, and we can have the demonstration of the instrument from our field engineers team. I would like to invite my field engineers team to have a demonstration of the instrument here. Yes.
Hi everyone. For power quality measurement, we have a dedicated instrument like power quality analyzer. Can you just open? With this help of this power quality analyzer, in any industry we can measure mainline monitoring and power. In this instrument we can measure active power, apparent power, reactive power, and percentage of harmonics, power factor, etc. Our another very dedicated instrument is a flue gas analyzer. With the help of this instrument in a boiler side, when we need to measure our nitrogen oxide or sulfur oxide, we can measure this parameter with the help of this instrument. When we are going for pumping efficiency, we need to measure power as well as water flow. For this purpose of measuring water flow, we can use this flow meter. With the help of this flow meter, we can measure water flow in any pipe. For chiller and HVAC analysis, we have also a very dedicated instrument and data logger facility also. That is a thermal hygrometer and thermal anemometer. And also for thickness, when we are going for measure water flow meter, we need to first identify what is the thickness of pipe. For this, we have a dedicated instrument, thickness gauge. We can measure pipe thickness with this thickness gauge. And for RPM, motor RPM measurement, we have a tachometer and a stroboscope, both. With the help of this instrument, we can measure RPM, what is the measure RPM comparative to what is the rated RPM of motor. This is our tachometer and stroboscope. And for thermal imaging, we have IR thermal imager. With the help of this instrument, we can identify how much temperature of any chilling system as well as heating system also. For main panel, somewhere we can find overheating of panel and lux cable. With the help of this instrument, IR imager, we can easily find the temperature and everything with respect to temperature. We have more instrument, out of which we carry here only 13 or 14 number of instrument for demonstration, out of which we have some data logger also for temperature data login for throughout the day. And we have also some temperature penetration meter, surface meter, and high temperature probe also we have for measuring up to 300 degrees Celsius temperature. So these are some instrument here, and in our office we have almost 35 and 40 numbers of instrument. And thank you. If anyone want to see how we can connect and measure the thing, we can check there. Thank you.
There are any water outlet from the plant, how they can minimize the water pollution or say the pollutant from the water body. Basically, we give a comprehensive energy assessment report, which is technically very thorough and implementable. So far, as like Rahul must have mentioned, we have completed around 22 now, or 15 plus 6, 21, covering cold storages, dyes and intermediate industries, CETP plant, diamond industry in Surat, then ceramic in Morbi, and recently in laminates in Gandhidham. And we are now reaching out to Porbandar, Okha, that area. So basically we are going by cluster by cluster, and Gujarat is like very unique in terms of certain cluster like ceramic, diamond, and cold storages in Himatnagar because of the many potato outcomes, potato produced here. So, so far most of this MSME has given very positive feedback regarding the report that we submit. Not only the report, after the energy audit, we help them for a technical implementation. For example, in a cold storage, many of the cold storages have IE2 motors, and they require a very fine speed control to maintain the temperature inside the room. I mean, the cold storages, there are multiple layers and the stack, and most of the cold air flow is from the top, and that circulate towards the bottom of the, so I noticed that to maintain the temperature at the bottom pile, let's say the potato, they put the potato here, they have to have a the very lower degree of the temperature at the top, and that may affect the product there because of not uniform the airflow at the bottom of the stack actually. So, but the important point is how precisely we control the speed of compression, and therefore we used to recommend VFD, which is standard, variable frequency drive. But most of, but IE2 motors are not compatible for VFD. They have to go with IE3, but then it's upfront investment. So, based on my limited interaction with the industries of 21 or so, they always be conscious about upfront investment. They are always having a limited fund for a capex, and in turn spending more money in OPEX, which is not the right business model. But I think the awareness, energy awareness program may help them to understand that there should be a reasonable fund allocation to capex so that we can save money in OPEX. And that is where I came to know why they go with IE2, not IE3 or so. Even many recent cold storages, they started now going with IE3. But I think there should be equal balance in capex versus OPEX. But the important part is, so far we have done most of these projects free of cost to the industry, and we would happy to continue that. But sometime industry should recognize that, okay, if there is zero investment to the energy audit, then they should seriously consider the report and implement. It's not like if something is coming free, that means there is no value. There are a lot of money going back, the back end to support the salary of this manpower. We have an instrument worth of around now 45 lakhs actually. All are high precision equipment. But I think our main objective is to how to cut short their energy demand without reducing their production outcome so that they reduce the energy consumption and help them for CO2 minimization. Okay. We would be happy to help industries around. IIT Gandhinagar being one of the institutes in this KISEM project, we are catering Gujarat and Rajasthan. So we started this activity June, July last year, and so far we covered Gujarat major sector, the cluster I would say. We are now scaling it up, but then we'll go to Rajasthan. So this is what our plan. This project is up to 2025, and as a part of the project, we are covering MSMEs, and then we'll go to SMEs as well. So this is the plan. If you have any question, please feel free to ask. We would like to have this session more interactive, and so at least we can help MSME. We consider this as an avenue to reach out to MSME. In addition to, like, we approach to GCCI, MSME in Udyog Bhavan, SGCCI, many MSMEs organization, we give the awareness program. Our team used to go, and we try to tell them that here is the organization, or here is the pool of the people who do energy assessment free of cost with all certified engineers, be certified energy auditors and field engineers. In addition to the team, we have a faculty colleagues, I think you have already mentioned. Two of us are from electrical engineering, I am from power engineering domain. My colleague, Professor Rajendran, is having an industry experience. He was with Bosch earlier and then joined IIT Gandhinagar. So he is coming with a whole industry background. So we people are from electrical engineering. Atul Bhargav is from mechanical engineering. He has a thermal engineering knowledge. And Chinmay is there as a part of this KISEM team. Chinmay, you know, he comes with the very good knowledge of water quality assessment. CRDTH lab here is for that only. So we are now trying to give the comprehensive solution. So far we have considered all energy, multi-energy vectors. Now we are saying the water quality assessment, and then finally giving a package like how much is the pollution control. So we give a full spectrum, energy, water and pollution, and that's how we will say what is the end objective in terms of CO2 emission or towards a more environmental friendly MSME operation. This is how we plan. But that is what the nutshell. We may, if you have any question, we can, you can ask. Otherwise, we can conclude this session. Very limited people, but I think you all have interest, and therefore you people are here. Your time is very precious than us. We are from campus only, but you came all over from outside. So I think your time has to be much utilized and should be more productive. Any question? No question? So what do you expect about delta T? Roughly, what is your guess? Let's say if I have that cold storage has how many stacks? 5 stack. 5 stack in Himatnagar only. We covered, I think, around 3 cold storages of very high level of sizes actually. So delta T, if you see from the top to bottom, what is your rough guess? 2 degree, 3 degree? What should be the guess? 5 degree? And do you think that 5 degree is the efficient, the cooling across the room of such volume? Maybe much higher than this room, I believe, in the height wise and the the dimension wise. It's not efficient at all. The reason being, most of the cold storage plants are designed in terms of the air density, the cooling density in a very typical manner. They should have planned with the proper airflow in a simulation first, and then say what is the product range. Let's say potato, I would say what we call bori, right? Potato bori of this height, and then how many stacks are there, and accordingly decide the free area with the storage area and decide. Is the delta T is from top to bottom, I think 3 degree or how much is it? 7 degree, right? 7 degrees is a delta T. You see the 5 stack itself is a 7 degree they have to maintain, which means if I want to keep 2 degree temperature at the last potato stack, that means I have to keep how much? Minus of something there, right? And that is not good at all for the first bori there at the top. It has to be uniformly distributed. Yes. So we have given a sort of design to at least reasonably uniform, have the uniform airflow across the volume actually. That's require a minor modification, but it's a very, I would say the phase 0 intervention with a better ROI. Most of the ROI in our case varying from 1 month to maximum 12 months actually. So this is unless we go with a high level of FDI, VFD actually, VFD, for a cold storage. Yes. Correct. Yes. You are absolutely right. In fact, that cold storage, there are 3 such 3 or 4, and we suggested only for 1. And that runs for most of the time during peak hours, peak season actually. Now is a peak season for them, and the February, March would be the dead time actually, right? There they do the maintenance actually for the cooling tower and all. But the point here is the VFD for all these 4 cold storages do not require that. The 4 compartment do not require that, correct? The cold storage is one of the examples because it's a nearby. Himatnagar is very nearby, but ceramic industry is the other side of the energy intensive MSME. I am not well aware about the how precisely and comprehensively the professional energy auditor do this kind of assessment, but I was told by many MSMEs, and this is the fact and the word by MSME only, they say, okay, when we do this through the professional auditors, they submit a sort of paper, and we may not even able to implement those energy audit measures actually. I mean ECM, energy conservation measures. It's a part of like we need to submit to BEE and therefore we do that. But then versus our experience, they say, okay, this one is very comprehensive and the sort of help that they are getting from our side all are implementable. They clearly see the benefit in terms of energy saving, cost benefit and in turn CO2 minimization. Which one? Which one? Standard one. I mean, we use every day, but stroboscope is where you don't have access. If that is the case, then it's required a stroboscope. Yeah.
Yes.
Any more question? No? Thank you very much.